Welcome back to a new week of learning in math class, specifically geometry. And today what we're going to do is we're going to practice some more flowcharts, talking about proofs and how we can prove two sets of triangles are similar to one another. So there's no warm-up for today. It's the first problem. Problem number 71 is actually a great warm-up problem based off the work that we did previously. So I would encourage you in your notebook to write down these triangles and draw them as they are, or if you've downloaded this, to pause the video and try and draw a flowchart proof for each of the following sets of triangles that you think are similar. And so to begin with, maybe start and identify which triangles you believe are similar. I'm going to do that, and then we'll do some flowcharts. Alright, so I've not yet written any flowcharts, and I'll do that here momentarily. But what I did want to address is that there are three sets of triangles that we have enough information right now in order to justify similarity. In letter A here, we can say that the triangles are similar by angle, angle. In letter B, we can say that they're similar by side, angle, side. In this problem, letter C, we don't have any angles, so we don't have enough information. We're actually going to talk about this one later today. But letter D, we also have angle, angle in order to justify similarity between those two triangles. And so what I'm going to do now, and what I would ask you to do, is go through and construct a flowchart proof like what we did yesterday, organizing these thoughts into a more succinct manner. So create a flowchart for letter A, letter B, and letter D, and then we will see how well we did. Alright, let's take a look at letter A and how you did. You should have two ovals up top to begin with. These two ovals represent the two angles that we know are equal. And again, I know that I have two angles on top, or two ovals on top, because I'm using angle, angle to justify the similarity of these two triangles. So I list the two sets of angles that are equal. I said the measure of angle A equals the measure of angle D. Measure of angle B equals the measure of angle E. Sorry, that got a little sloppy. Then these point to the conclusion of our two triangles being similar, and remember we call this a similarity statement. So I said triangle ABC, and the order does matter now when I write my second triangle. A and D correspond, and so do B and E, as do C and F. So I said triangle ABC is similar to DEF, and the reasoning for that is by angle, angle similarity. Then as we move on to the second one, as we look at problem number, or letter B rather, if I can get my work to cooperate along with me here. Here's the second one that I did, and on this second problem, letter B, you can see that I wrote side, angle, side because it was a set of sides, another set of sides, and the angle in between that was equal. What I want you to get in the habit of is writing the ratio of sides. So IH over JL, those were the corresponding sides. That was 16 over 12, and that equals 4/3. That's the same ratio as the other set of sides, HG and LK, that correspond to one another, so that makes 4/3. And the angle in between both sets of those sides were equal, as denoted by the right angle. So therefore I can conclude, using these three facts, that triangle IHG is similar to triangle JLK by side, angle, side similarity. The last problem then that we asked you to do was letter D, or that I asked you to do, involving the work of angle, angle. So again, this has two ovals on top. I said to start that angle M was equal to angle M, as was angle S equal to angle V. Therefore, by angle, angle similarity, these two triangles, MSN, is similar to triangle MVT. Hopefully that went okay for you. We're going to move on to the next problem. Problem number 73 offers us a challenge. It says, are the triangles at the right similar, and how do you know? And so what we're going to do is we're going to do a flowchart again. It'll be a little bit more practice with our flowcharts. And just looking at this information, hopefully you can recognize that if we're going to justify similarity here, we're going to use the longer set of side here with this one, and then this other side length over here of 17, that would correspond to this one. And we know that the angle in between those two sides are the same as denoted by that one arc. So this is a perfect candidate for us to be able to use side, angle, side similarity. And so I would like us to construct a flowchart in order to organize our work. So let's do that right now, create a flowchart justifying the similarity between those two triangles. So hopefully you're going to have something that looks something like this. I have side angle side, and you should write again the ratio of the corresponding sides. We know that PQ corresponds to YX, and that ratio is 23 over 23, which is 1. Then I also have these two angles, Q and X, being the exact same measure. As do these sides correspond, I have the same ratio of 1 and 1, therefore these triangles are similar by side angle side. And so hopefully we're able to reconcile any differences that we had on that problem. But what I want to highlight is the second one that says, or the second letter on this problem that says, hey, these triangles aren't just similar, they're congruent, he says. What special value in our flowchart indicates that? Hopefully you can see that this value of 1, the scale factor or the zoom factor between the sides is 1, which means that these triangles are more than similar, they're actually congruent to one another. And so letter C, what we're going to do is we're going to write a conjecture from our observations, and what that conjecture is going to be this, and this is something worth writing down in your notebook or in your notes, that says if two triangles are similar with a scale factor of 1, we're not going to say that they are necessarily similar, or they are similar, but we're also going to conclude something more specific in the fact that they are congruent to one another. Remember, congruent means the exact same. So if two triangles are similar with a scale factor of 1, not only are they similar, but more specifically, they are congruent to one another. And so that is the observation that we made from this problem here. Moving on to the next section, section 3.2.4, it says more conditions for triangle similarity. It says so far you've worked with two methods for determining that two triangles are similar, angle, angle, and side, angle, side. It says, are these the only way to determine if two triangles are similar? Well, what we're going to do now is we're actually going to add one more triangle similarity condition. And so over here, I'm going to write conditions that work for triangle similarity. And the two that we already have are angle, angle, and side, angle, side. Excuse me, side, angle, side, not side, side, angle. But today what we're going to do is we're going to add a new one to our list, and that is side, side, side. And so if we have three sets of sides that are all proportional, we can conclude that the triangles are similar, and we'll show you how that happens here in a moment. But something that I think is worth while writing down are conditions that don't work. And so there are a few conditions for us that don't work when it comes to triangle similarity, and one of those would be side, side, angle. That's something that does not work for us, and so I just wanted to highlight that as we move forward. But I'm going to show you now how we're going to deal with this idea of side, side, side. So if you go to the next problem, we're going to practice it a little bit. So on this problem, I'm going to kind of ignore some of the directions that it's asking, but what I want us to do is to identify if we're given from here on out two sets of triangles that are only given side lengths, so we have nothing true about the angle measurements within them. What we need to do is we need to match up corresponding sides. What I mean by that is let's highlight the shortest length in each triangle, so like 4 and 6 here. Those are the shortest sides. Then what I'm going to do is I'm going to match up the next longest sides, which would be 6 and 9 in this case. And then I'm also going to highlight the longest side length in each triangle, which would be 8 and 12 respectively. And then what I'm going to do is I'm going to write out those proportions. I'm going to say side length 6 corresponded with 4, and that's the same thing as 1.5. And I also know then the next set that I had was 9 over 6, and that's the same thing as 1.5. Okay, and then the last set of sides that I had were 12 and 8. 12 over 8, well, that's also 1.5. And so what side, side, side similarity is stating is that if you have three sets of sides that are proportional, like what I have here, the zoom factor between all of them is 1.5, that is enough information, therefore, to justify that those triangles are similar to one another. So side, side, side similarity is our third and last set of conditions to be able to justify whether two triangles are similar. And so just like we've done with the previous problems, we can also construct flowchart proofs for this. And so if I was going to do a flowchart proof, I'm going to have three sets of ovals again. And above these three sets of ovals, I'm going to put S, S, and S because we're going to use side, side, side similarity. Those are the facts that we are going to use in order to justify our conclusion. And so in the first one, what I'm going to do in this first oval is I'm going to write the side length DF over AC. So DF over AC, those were the shortest sides, and we said that that was equal to 6 over 4, which is 1.5. And so when you're doing proofs with side, 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 you want all three ovals to eventually have this zoom factor of 1.5, or you want them all to be the exact same in order to show that the proportionality between each side is the exact same, where the enlargement factor between each set of sides is the same. The next set of sides were BC and EF, so I can say that BC corresponds to EF, and that ratio of sides was 9 to 6, which is the same zoom factor of 1.5, sorry about that. And so yeah, that again hits the exact same thing that we wanted, zoom factor of 1.5. And then the last set of sides that we were dealing with was those longest sides. And so in this instance, that would be DE corresponding with AB. So I'm going to write DE corresponding with AB. And those side lengths were 12 and 8. So I'm going to say that that's the same thing as 12 over 8. And if I type that in my calculator, I'd get 1.5 again. And so that's great because all of the sides are proportional. And therefore, side, side, side similarity says that we can then conclude that those triangles are similar. So I draw an arrow from all of those facts to our similarity statement now, which would be stating that triangle ABC is going to be similar. Now be careful how you write this. Triangle ABC would be similar to DEF. And now I'm going to write side, side, side similarity. So this was really just kind of the biggest thing for today. Today was more practice with flowcharts, and we added one more triangle similarity theorem, which was side, 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 and you can add that to our repertoire of already used similarity conditions. So we have now angle, angle, side, and side, side, side. So to recap, last page, this just goes back to what we've been doing over the last few days dealing with a flowchart. It helps you to organize facts and indicate which facts lead to a conclusion, and we usually use these most of all for our work with dealing with triangles and whether or not they are similar to one another. So hopefully you're feeling somewhat comfortable with flowcharts. We're going to be taking a test at the end of this upcoming week, so this is going to be Friday, April 17th. If you have any questions, feel free to swing by my office hours. As a reminder, that's from 11 to noon every single day. You can click on the link on Canvas to come join me. Otherwise, stay safe and stay healthy.